Hello. In this video, I'm going to talk about measurements. We're going to go through some measuring rules as well. We have measuring rules because as I try to measure something, for example, if I wanted to measure this table here with my yardstick, well, there might be some different ways that people do it. People might read different numbers. We get all sorts of different values for the length of this table, but the length of the table is not changing. People are just measuring different numbers, right? Maybe somebody doesn't use this yardstick. Maybe somebody uses this ruler instead. So we end up with different things. Well, what we're going to do is we're going to set some rules for our class so that we make the same measurements. So we get very, very close. This is important to standardize our measurements because as we go outside of school, more typically, the measurements that you make are going to be used to maybe build something, or maybe you're in the kitchen and you need to bake something, right? It's important to get these measurements correct because if you make, in baking, for example, if you put too much water, too much milk into your cake, perhaps, then it's going to come out maybe runny instead of a nice spongy texture, or maybe too much flour and then it's too dry or it burns. You know, all sorts of these different things that we have to do in order to get standard measurements. One of the most common things that we measure is going to be length. We're going to use meter sticks. This is a yardstick, but we're going to use meter sticks for those, as well as rulers are going to be powerful tools for that as well. We're also going to measure weight. We're going to use scales. This is just a standard bathroom scale here, but we can also use triple beam balances. And so we'll use those in classrooms to measure mass. So let's go ahead and talk about our measuring rules and how we can get these standard measurements down. So I'm here at my computer now. I'm going to walk through our measuring rules. Again, these rules are put in place for us so that we get about the same measurement. Again, we talked about the table. If we're measuring the table, we would expect that we all get about the same answer. Now, one thing that there's always going to be with any measurement is this thing called uncertainty. And uncertainty is basically just the unknown. There's going to be a little bit of error in a way that comes with our measurements because there is no such thing as a perfect measuring tool. We can get close, but we will never have that. So we might not get exactly the same measurement, but we want to get as close as we possibly can. And that's what these rules here that we're going to talk about will help us get to. So rule number 1. This one is more so helping us with our math and dealing with the measurements after we have them. But for us, we're going to measure in decimals and not fractions. So decimals are good, fractions are bad. All right, so decimal is going to be like 0.5 or 4. Goodness, I cannot write. There we go. Let's try that again. 4.567 is a decimal. Fractions would be things like 7/10, 1/2. These we don't want. These we do want. We do want decimals, not fractions. All right, so fairly straightforward. It might be a little bit different than ways that you have done in the past, but it's going to tie into the way that we use our ruler, and I'll talk a little bit more about that when we get down there. Rule number 2 for us here. We're going to write everything we know. And when I say everything, I'm talking about specifically digits that you know. Digits representing numbers in specific places. For example, the number 1,251 has a digit in the thousands place, a digit in the hundreds place, a digit in the tens place, and a digit in the ones place. I could add on here and say maybe 1,251.53. Now I have a digit in the tenths and the hundredths place. So these places here represent a digit. So we write as many digits as we know. Now, we don't have to go out and say, well, I know that it's less than 10,000, so I don't need to put anything in the 10,000 place. I don't need to put those leading zeros there. And again, those will come up more a little bit when we talk later. But we focus on everything that we know in each digit. So, for example, if I didn't know 6, 7, 5, or whatever, I don't want to add those on because I don't know those, right? I want to only write the things that I know. And as of right now, I only know the 1, 2, 5, 1, 5, 3. Now, rule 3 changes that a little bit, where rule 3 comes in. It says that we are allowed to take, there we go, take one guess digit. So this guess digit comes in at the end of our number, or to the right. Sorry if my handwriting's a little sloppy there. So we can take one guess digit at the end of our measurement. So let's go back to our number from before, 1251.53. So I measured this. I know these numbers, all of these 5, 6, goodness, I can't count. 6 numbers here that I'm going to underline in blue. These are the things that I know. Now, I get one guess digit. So I can say, looking at my ruler, I get to guess somewhere in between. And now, depending on the ruler, that guess will change where it's at, but it's always going to be the last number that you write. So, for example, if I think it's about halfway in between, I'll write about a 5 there. Maybe I think it's a little bit less than that halfway. So maybe I say 4. But what I can't do is I can't say 5, 6. I can't say, oh, well, it's a little bit more than halfway, but maybe not quite all the way there. I only get one guess digit. So I can say this 5 here, this is my one guess digit. And that's really important. That's a very common mistake that people make, is that they'll guess more than one. Or sometimes they will forget this guess digit. So make sure that you remember that you do get that guess. Rule number 4 is another easy one to forget. We get a little bit lazy sometimes and want to just write our numbers, but we need to be able to communicate what those numbers are. For rule 4, we include always, when we write numbers in science and physics, we include our units with those numbers. So whether we're measuring length, maybe we'll include meters with the digit M. Maybe we'll use centimeters. This will be, most of the time we'll use centimeters, sometimes meters. Very, very rarely, almost never, will use inches, but outside of physics, you might use that. So this is not really in physics, not used in physics. We'll use those. Oops, I just realized I made a little mistake there. Let's fix that. Centimeters. So we use meters, centimeters most of the time for length. For things like mass, we might use things like kilograms or grams. We'll have another video here that talks about these units more in detail and kind of what they mean, but maybe we use kilograms. Let's see, what else? What's another unit that we could use? Well, volume, the amount of stuff, the space that things take up. Maybe we'll use milliliters. Okay, and so these symbols here we include after our number. For example, 5 meters, or 6 kilograms, or 7.34 milliliters. By including those units, that tells me what that number represents. If I were to just write 4, well, it could be for what? It doesn't mean anything for science. Science, we want to give those numbers meaning. So we always include those units. All right, let's take a look at some examples here. And I want to talk a little bit more about this ruler. You're going to see pretty common, this is a little bit shorter version of what you'll see more of the time in class with a ruler, or maybe a meter stick will look a little bit differently. But a ruler is going to look something like this. On one side, we have inches. On the other side, we have centimeters. We can tell the centimeter side in a couple different ways. The centimeters are, in this case, on top, and the inches side is on the bottom. So that means that we're going to be pretty much using this top part here. Centimeters are shorter. So this is 1 centimeter there than an inch. An inch you can also measure is usually about the length of your knuckle from when you bend your finger, kind of like a hook. Usually about that. That's a way we can approximate it. It's not always exactly, but anyways, centimeter is the shorter one. There's also this little mm, the millimeter marking. So that means each one of these little lines in here that we can see within that little circle, the really tiny lines, represents 1 millimeter. The bigger lines, like here, this is 1 centimeter. So going back to rule 1, which I have listed right here. Oh, can't draw on that. Maybe. There we go. Rule 1, use decimals, not fractions. That's because in centimeters and meters in general, the metric system, it's all based on factors of 10. So what that means is each little line here, so let's say, for example, that line is maybe not the best. That line is going to represent 0.1 centimeter, which is 1/10 of a centimeter. Halfway in between is going to be 0.5. We can count all of these little lines, and each one just counts up. So we have 0.1, 0.2, 0.3, 0.4, 0.5. That's halfway. 0.6, 0.7, 0.8, and so on. And so it makes it really easy for us to write these decimals based on the centimeters side. Where if we flip over to inches, well, you might think, well, halfway, that's pretty easy, right? It's halfway. It's 0.5 again. If you want me to write in decimals, I can do that. Well, what about if we get like in here, and this is actually a bad example of a ruler here, now that I'm looking at it, which is kind of frustrating, but it's okay. So we get in here, this inches side is built more on fractions. So it's going to say 1/2, and then there's usually going to be another half in there. So that's going to be 1/4, and then there's going to be another one in there, and that's 1/8, and so on. And that makes it difficult because then you can go, okay, 1/2, that's 0.5, 1/4, that's 0.25, and maybe we get to 1/8, and all of a sudden it becomes, okay, well, what's 0.8 again, or sorry, 1/8 again, and it becomes a little bit trickier. So the inches side is built upon those fractions. And so that's why we use centimeters and meters rather than inches. So that's something you want to be careful of as you measure things for our classes, that we want to use centimeters or meters as our measurements, because again, it makes it very easy because it's built upon these decimals rather than fractions. So let's take a look at some actual examples and walk through the rules, and hopefully that didn't confuse you more. So right here, this orange rectangle, I'm going to try to take this measurement here following our 4 rules. Rule number 1, scrolling back up here, use decimals, not fractions. Okay, so I'll just keep that in mind as I write this out. I'm going to write it in a decimal form rather than a fraction form. Rule 2, write all the digits that I know. Okay, so I'm going to take a look here. Well, we start at, oops, I don't want to erase that. There we go. They start at 0, or right about 0, the best I could draw it when I drew it in. There we go. 0, and I'm going to come out here, and the other end reaches right about there. And I can zoom in a little bit, make this bigger for us. So I go from 0 out here, just shy of 500. So I'm going to write everything that I know. Well, I know for sure that it's at least 400. It's not 500, so I know for sure that place. Then I know as well, I've got these little markings that also tell me things that I know. The ruler is what tells us these things that we know. So this, looking at it, this should be markings of 10. And I can double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, perfect. So that means that this is 400. So I go one more. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90, which makes sense. I'm right before 500. So looks like I'm just before 90. So I'm going to say I know for sure that I'm at least at 80. And then looking more, I don't have any smaller markings on my ruler, so I don't know any more beyond this. This is all that I know. So I know for sure 480. Then I check rule 3, I guess the next digit. Well, my next digit is in the ones place right here. So I look pretty darn close to 90, right? 90 is right in there, but not quite at 90. So I'm going to say I'm 489. Lastly, rule 4, write the proper units. So I'm going to include my units here, which I'm not given them on this ruler. So let's just say that it's glugs, just some random made up unit here. So I'm just going to write glugs, 489 glugs here. And that's my measurement for this orange rectangle. All right, so I followed all 4 rules. Let's take a look at another example. Scrolling down here, this spring. So once again, this spring goes from 0, and when it's 0 is not on here, it's the edge of that ruler there. Another common thing, sorry, that I should mention here. Sometimes you'll see a ruler that has like the edge of the thing is here, and let me draw it in. Let's go brown, like we're actually looking at a wooden ruler. Sometimes it'll look something like that. We want to make sure that we measure up marking with the line that's marked for 0 and not the edge of the ruler. Because the edge of the ruler isn't always 0. But if there is no 0 listed on the ruler, then the edge is 0. So back here, spring's at 0. Then I go to the end of the spring somewhere in there-ish. I'll try to get it lined up. There we go. So looking here, I know very little. This ruler doesn't tell me a whole lot of information. It tells me 1, 2, 3, 4, 5, 6, 7. It tells me my ones place. So I know for sure this ruler is at least 6. Again, whatever this is. Let's change this one up. Let's say this is centimeters here. So I know for sure this is at least 6 centimeters. I know it's less than 7, but how much? Well, that's where now my guess digit comes in. So I'm less than 1. So now I'm in a decimal. I'm in the tenths place. That's 1/10 or tenths place, like that. I'm definitely over halfway. I don't look super close. I'm going to say I'm about 6.8 here. So I'm definitely over half. Not quite all the way there. I wouldn't say quite 0.9. But again, this is a guess. So if you feel that it's closer, if you think that it's 6.9, make it 6.9. Maybe you think it's a little bit shorter. Maybe you think it's 6.7. That's okay. But we should all be around there. We should all for sure have the 6 on this measurement. And then we should be greater than the 0.5, definitely, in this case. So let's take a look at a different example here. Oops, I forgot my units. That would have been bad, right? Always include those units. See, it's a very easy thing to just do and forget. So let's take a look over here at, I'm going to zoom in on my graduated cylinder. Take one zoom out. There we go. Graduated cylinder on the side here. So graduated cylinder here, this is measuring volume. So this is filled with water up to the line. Here, again, 0's down at the bottom. And we're going to measure to the bottom what we call the meniscus. You might remember this from chemistry. Bottom of the meniscus tells us where the water is lined up, the actual volume of the water in the graduated cylinder. So we're going to write out what we know to start. So I see here I have ones places again. The ones place is marked out. We see 5, 10, 15, but this is going to be 1, 2, 3, and 4. Each little line represents 1. So I see for sure this is 35, 36, not quite at 37 for me. So I'm going to write 36. So I know the tens place because now I'm greater than 10, and I know the ones place. So now that I know the ones place, I get to guess the tenths place. So looking here, this is pretty darn close to 37. So I'm going to go 0.9, so 36.9, and I include my units. So again, I've written in decimal form, rule 1. I wrote everything that I know, the 3 and the 6, 36, rule 2. Then I made my one guess digit, rule 3, and I included my units, rule 4. So these rules apply not only for length measurements, but also volume measurements. So let's take a look at this other one. With this example, we have a green rectangle and then a ruler that goes out to 10. But we don't know anything in between. So what do? Well, let's just follow our rules. 1, write in decimals. Okay, I'll keep that in mind. Rule 2, write everything we know. Well, all I know is that it's less than 10. So if I write in my tens place, here I'm putting a 0 for that. Okay, and this is just temporary. I'm not going to keep that 0 there. So I know that. After that, I don't know anything. So what do I do here? Well, that's where my guess digit comes in. We always get to guess a little bit. So I know for sure, based on this, pretty confident in saying that this is less than halfway. So this would be less than 5. Doesn't quite look like 4 to me. I'm going to say 3, and this becomes my guess digit. Let's just call this meters. So I'm going to say that this rectangle is about 3 meters. Now, a very common thing that people might want to do here is maybe say 3.2, because you say, well, I always get a guess, right? And that guess often comes in that tenths place. But in this case, we only get to guess the one thing that we don't know. We get 1. So I've guessed my one digit, 3, and that becomes my measurement. So again, my final answer here is just going to be 3 meters. I'm not going to worry about that 10 there, and that is my guess digit. So again, we always get a guess digit with our measurement. So hopefully this clears it up. If you have any questions, please feel free to let me know. Hopefully we follow these 4 rules and they make sense, and we'll get lots and lots of practice with them. But thank you for taking the time to watch. I really appreciate it, and have a great rest of your day.